Hello math students, math teachers, and parents out there on the World Wide Webs. My name is Mr. Galindo, here to demonstrate a really cool math and art project known as a spiral of Theodorus. Here's an example of a finished product. Here's another one. And one more. This is a really great project to do when students are learning about the Pythagorean theorem, and also a really great activity to actually see what irrational numbers look like in terms of distance. I got this idea through my subscription to Mathematics Teaching in the Middle School, a monthly magazine published by the National Council of Teachers in Mathematics. If you're a teacher watching this, I highly recommend getting your membership to NCTM, which will come with a subscription to one of these magazines, depending on the grade level you're teaching. And I will attribute to the exact article and author down below, although I have made my own adjustments to this project, so it won't be exactly the same as you'll find it in that original article. But anyhow, let's go ahead and get started. Okay. We want to make a spiral of Theodorus. So we're going to need some computer paper, a ruler, a pencil, and an index card. Now, we won't need the index card at the beginning, so I'll set that to the side. I'm going to grab my ruler, and I'm going to position my paper in a landscape position, and I'm going to mark the halfway point of the length. So if I measure the length of this paper, I see we have a length of 11. I'm going to half that, mark the halfway point, which is 5.5 inches. And I'm also going to mark that point on the bottom. I'm going to draw a line through those 2 points. And what I'm doing here is I am placing a y-axis in the center of my paper. Now I'm going to draw an x-axis by repeating the same process, but along the width of the paper. The width of this paper happens to be 8.5 inches. So 8.5 divided by 2 would be 4.25, which is right there. I'm going to also repeat that on the right side. And connect those 2 points with a line to build my x-axis. Now, when you do have your students make their final spiral, they can use this. They can use any position they want. But just to get them started, I do like to just start with a landscape position. All right, now I'm going to mark my point of origin, and I'm going to build my very first isosceles right triangle. And I'm going to measure an inch starting at the point of origin to the right along the x-axis to make my first leg of my isosceles right triangle. And I'm also going to measure an inch going to the top along the y-axis to make the second leg. And I'll go ahead and just mark this with a 1 here and a 1 here to remind myself that the length between these 2 points is 1 and this length here is 1. I'm going to connect those 2 points to make my hypotenuse. All right, now I'm also going to remind myself this is a right triangle by drawing the little square in the bottom left corner. This is where your index card comes in. We're going to mark a point that's exactly 1 inch from the corner. I don't know if you can see that, but using your ruler, you want to mark the distance of 1 inch along the corner. And we're going to use this index card to repeat right triangles. Now, our very first triangle is an isosceles, but from now on, the rest of our triangles are not going to be isosceles, but they will be right angles. They will have right angles, so that they're going to be right triangles. And in each case, we're going to position our right angle on the, I guess we can consider it the right side of the hypotenuse. Yeah, we're always going to position our right angle on the right side of the hypotenuse. So we're going to place our index card along that hypotenuse, and using that point that we indicated, we're going to draw our first side length. Well, actually our second side length of our right triangle. We've got our hypotenuse, which is going to be our first side length, and then close that triangle by going back to the 1 inch mark we marked on our y-axis. And again, to remind myself that this is a right triangle, I'm going to draw my little box, my little square in the bottom right corner. And I'm going to keep repeating this process. And that didn't come out so precisely, so let's try that again. Making sure that the index card is lying right on top of the hypotenuse. And then you're always going back to that that point to close your triangle. Again, I mark my 90-degree angle, and I keep going. Now we're starting to see our spiral take shape. I'll do one more. Okay, now I got mine going here, and once you got 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 more right triangles, you might want to start a conversation with your students about, well, we've started about the side lengths of the hypotenuse that we're showing here. Because basically we're just showing a bunch of different right triangles with a bunch of different sized hypotenuse, and they're increasing in a very special way. So let's draw our attention to that first right triangle that we started with, which happened to be an isosceles. And at this point, a good thing to ask students is, how we know that this length from this point to this point is 1 inch, and we know that the same is true for the other leg, 1 inch and 1 inch. How do we know, is there a way we can find the length of the hypotenuse? Now, as I said at the intro of this video, this is an activity that works really well after you've presented on the Pythagorean theorem and after your students have some comfort level with that. But it's also good to just have them think in a very basic way about figuring out how long this piece is by considering the ruler, right? We can actually use the ruler to try to find the length of that piece, of that hypotenuse. And if we're using the ruler, we can basically come up with a pretty good measurement, which is going to be, let's count it out. This is 1 inch. So 1, 2, 3, 4, 5, 6 sixteenths. So 1 6/16 could be a possible measure. Let me zoom that in. So let me just repeat that again. 1 inch, and then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And again, you can kind of see where it might not be directly clear, but let's just say that we've made an approximation of 1 6/16 or 1 3/8. And then at this point, you can challenge your students to see if they could find that length using the Pythagorean theorem. So you can do it with your students, or you can have them try it on their own, or with an elbow partner. But it really depends on the comfort level of your students with the Pythagorean theorem. We can label our first leg as A and our second leg as B. We know A is 1, B is 1, so I'm going to substitute those values into my Pythagorean theorem, and I'm going to work it through. 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, and therefore, if I take the root to both sides, I can find my value of C, which is the square root of 2. So, and if you've already talked about decimal approximations, you can also have them write an approximate decimal value as 1.414. So, in this activity, I do like to have my students label the hypotenuse with the irrational number. But you can also, even with the students who are comfortable with Pythagorean theorem, let them know that they can try to measure it with their ruler. And if they do that, they can actually get a pretty close approximation. Let me show you what I mean. If I put my ruler along the hypotenuse, I can count one the other way. I can count 1 inch here, and then 1, 2, 3, 4, 5, 6 sixteenths. So let me kind of put that over here. 1 6 sixteenths as an approximate measure of my hypotenuse. We know it's rad 2, but we can also approximate it as a mixed number of 1 6 sixteenths or 1 3/8, or 1 in 375 thousandths. And see how close that approximation is to the approximation of the square root of 2 in decimal form, which would be 1.4142. And some of your students, when they measure the hypotenuse with the ruler, might come up with a different measurement of 1 7/16, which gives us a decimal of 1.4375. And you can have a discussion about how this number really is right in between these two numbers. So to kind of reinforce the idea that the square root of 2 is the most accurate representation for this distance of the hypotenuse. Now, the next part of this, and again, this really depends on the comfort level of the student, is to challenge the students to come up with the hypotenuse for each, the length of the hypotenuse for each right triangle. Remind them that we've measured 1 inch along the spiral, but then challenge them to come up with the other lengths of the hypotenuse. And since we know the outside part is 1 inch, we know that this leg of the next triangle is rad 2, we can set up the following equation using the Pythagorean theorem. Again, this depends on comfort level with Pythagorean theorem. Now, this is where it gets really interesting, because we have our first perfect square number, which gives us a root of 2. And this is where, when you revisit the ruler, you can actually see the 2 inches real nicely along the hypotenuse. So this project really helps to reinforce the idea of irrational numbers in terms of their place on the number line. So we can see that we saw that the square root of 2 lies somewhere between 1 3/8 and 1 7/16. But when we got to our perfect square number, we saw that it really matched up nicely with our measurement of the ruler. The square root of 4 is 2. And here we see the measure of 2 inches on the ruler. I'm going to keep working out the Pythagorean theorem for the other hypotenuse. So 2 squared plus 1 squared equals c squared. Now, at this point, it should be quite obvious that the hypotenuse increases by a natural number underneath the radical. If I were to do the Pythagorean theorem using square root of 5 squared plus 1 squared equals c squared, I would inevitably get the square root of 6 on this hypotenuse. I would get the square root of 7 on this hypotenuse, the square root of 8 here, the square root of 9 on this hypotenuse. And again, when you see a perfect square, take the opportunity to verify that on your ruler. And again, you'll be pleasantly surprised to see how nicely that number also appears when you measure it on using your ruler. But this pattern continues on. And again, the pattern is pretty straightforward. And when I give this assignment to students, I do like for them to show me the Pythagorean theorem at least, I would say 3 to 5 times. But you also don't want to go overkill because it does get quite redundant. Here's 16, which is 4. And again, my 4 should appear there on the ruler. All right. And there we have our beautiful spiral of Theodorus, where we can see the irrational numbers represented in the spiral, and where we can see their approximations using a ruler. Now let's share with you some really nice artwork that came from this project. So here's one that the student used, kind of like making the spiral like an instrument playing music. This student just colored it out, is showing the use of the Pythagorean theorem for the first values. Here's another colorful example. And by the way, this is also known as a wheel of Theodorus too. So you can call it the spiral or wheel. Here's a sea creature of some sort. Now this is an interesting one because, and you'll see this too with students, but sometimes they'll have trouble making their right angles like this student did. See how? That's why it does take a round of practice sometimes to really get the students to get on the right path. See how this is definitely not a right triangle, but still looks great, I think. Here's an interesting one. This student didn't center her paper, so, and I tell the students that, you know, you can just try to keep going with it, but this student decided to attach an extra piece of paper to show the pattern, which is really quite nice the way she colored it. Here's another example. This is using the spiral of Theodorus as a football helmet. So this is irrational numbers representing a piece of artwork. And Again, the main point in this project is to draw the students' attention to the idea of how irrational numbers can be represented using lines. So, and they can be verified by using the ruler. So here we know that this length is square root of 9, which is 3, and we can prove it by measuring that with our ruler. Again, it's just an activity to help tie the concept of irrational numbers with distance along a line segment. Alrighty, thank you for watching this video, and please post your questions or comments below. Thanks.